All right, so here's a question from the JEE Advanced 2021 Maths Paper 2, and it's a relatively simple problem on the products of vectors. So let's try this problem. It says let O be the origin and the vector OA be 2i plus 2j plus k, and vector OB be equal to I minus 2j plus k, and OC is equal to half of OB minus some lambda into OA for some lambda greater than 0. If OB into OC is equal to 9 over 2, then which of the following statements is or are true? So we basically have four separate mini problems embedded into the problem, and we'll get to them one by one. First of all, what intrigues me is what will be the value of this constant lambda. So let's try to figure that out. So the one condition that we will start with is the one that is given right here. It says that vector OB times vector OC, this is equal to 9 by 2. Now we can write vector OC in terms of the two known vectors. So this can be written as, this equation can be written as vector OB times half of OB minus lambda into OA, this equal to 9 over 2. I can take this half here and then cut the 2 into the denominator there. And this will give us vector OB into vector OB, this cross product, minus lambda into vector OB multiplied by cross product with vector OA. And this is equal to 9. Now these are the two same vectors, and we know that for any two parallel or anti-parallel or same vectors, the cross product is equal to 0. So this comes out to be just lambda. Lambda is again a positive number, so this negative sign also gets cancelled out. Lambda multiplied by the magnitude of OA into OB, this is equal to 9. Now we know what OA is, we know what OA is, and we know what OB is, so we can figure this part out, and then we will be able to figure out what 9 is, what lambda is, sorry. So I'll do this by the determinant approach to write vector OA into cross vector OB. So 2, 2, 1, 1, negative 2, 2, and this is I, J, K. Let me put the hats right there. And so this comes out to be equal to, well, once you cover the I part, you get 2 into 2 minus 2, so that's 6I. Then minus 2 into 2 minus 1, that's minus 3J. And then, again, once you cover the K part, you get negative 4 minus 2, so that's negative 6K. So the magnitude of this vector, the magnitude of vector OA cross OB, this is equal to the square root of 36 plus 9 plus 36, that is square root of 81, or 9. So this thing right here, this is equal to 9, so that gives us the fact that lambda is equal to 1. So that saves a lot of computations that would otherwise have been really hectic. So we know what OA is, we know what OB is. Now the vector OC, that is equal to half of OB minus vector OA. So this is equal to half of vector OB is 1, negative 2, 2, minus 2, 2, 1. And this is half of what? 1 minus 2 is negative 1. Negative 2 minus 2 is negative 4. And 2 minus 1 is 1. And so the vector OC is then equal to minus I over 2 minus 2j cap plus k cap over 2. Vector OA, again, let me just write it just for reference. Vector OA is 2, 2, 1, so 2i plus 2j plus k. And vector OB, that is equal to I cap minus 2j cap plus 2k cap. I hope I've not committed any mistakes right there. All right, so those are, let me just verify it. OC is half minus 1. So OA, we have OB minus OA. So everything looks fine to me. All right. Now let's go on to these mini problems that we have. The projection of OC on OA is -3/2. So the way we do these problems, the projection problems, when you want to find the projection, the magnitude of the projection of a vector on another, so of vector OC, so this, let's say this is the point O, this is C, and this is A. So we need to find what the projection of OC on OA, all right? So we basically need to find this distance right here. And this distance right here, if you notice it carefully, if this angle is theta, so this distance right here is OC cos theta, or you can write this equivalently as OC dot OA divided by the magnitude of OA. This is again a standard trick. I just wanted to recall this. So OC dot OA, we just have to multiply it component wise. So 2 into -1/2 is -1, 2 into -2 is -4, and then 1 into 1/2 is +1/2. This divided by the magnitude of OA. This will give us the magnitude of OA is equal to 2 squared, that is 4, plus 4 plus 1, and that's just equal to 3. So this is just equal to 3. Here you get, on this side, you get -5 plus half divided by 3, or this is -9/2/3, or -3/2. So this value, -3/2, is actually the same as what this option asked for. So this one is correct. So option A is correct. Let's move on to the second problem. The area of triangle OAB is 9/2. So OAB, triangle OAB. So remember that the triangle formed by two vectors. So OA and OB. Sorry, not to draw any arrows here. The area of this triangle is equal to half the cross product. So this is equal to half the magnitude of the cross product. So half of the magnitude of OA cross OB, but we already did calculate OA cross OB. That came out to be 9. So the area that comes out to be equal to 9/2, and that's what also, so AB is also correct. The area of the triangle ABC, now this is a bit longer. So we have the triangle ABC this time, ABC. So we know what OA is, we know what OB is, we know what OC is as well. So vector AB, well, that is just equal to OB minus OA. Similarly, vector AC is equal to OC minus OA. And we can also do the same thing for the third one as well. We don't really need to do it, but anyways, this will be OC minus OB. Now, we just need two vectors, so let us just figure out the first two. The vector OB minus OA, this vector right here, again, I'll write it in the angular brackets. OB minus OA gives -1, comma, -4, comma 1. OC minus OA, it gives -5/2, then -2 minus 2, that is again -4, and half minus 1 is -1/2, and we now take the cross product of it. So the cross product of this is -1, 4, -5/2, -4, -1/2, and IJK. And we just, once we figured that out, we half it to get the area of the triangle. So in the I component, you have -4 into -half, so that is 2, and that plus 4, so that is 6I cap. And then in the j cap, so we have -j cap, we have half plus 5/2, and then in k cap plus k cap, we have 4 minus 4 into 5/2. I guess that is correct. We'll recheck it once. So this is 6I cap minus 3j cap, 4 into 5/2. That gives us 10. So that is -k cap, -6k cap. And the magnitude of this times half. This, again, the magnitude of this is again equal to 9. We just saw another variation of that before. So 9/2 is the area of this triangle ABC. So this is also correct. Let us try the fourth option, whether it is correct or not. The acute angle between the diagonals of parallelogram with adjacent sides OA and OC is pi/3. OA and OC is pi/3. So how do we figure that out? So the parallelogram now looks something like this, and we are supposed to find the angle, the acute angle between the diagonals. So this angle right here, we're supposed to figure this one out. If we there can be multiple approaches that we can try in this one. One single approach is, since this is the origin, we know what the coordinates of A and C are. We know for a fact that this midpoint bisects these both of these diagonals. So this midpoint, this M right here, if we want to write out its coordinates, it's basically the midpoint between A and C. So the midpoint between A and C, that is equal to 2 minus half, that is 3/2. 3/2 is 3/4. Then 2 minus 2 is 0. 0/2 is again 0. And 1 plus 1/2 gives you 3/2, so that's 3/4. And what we can do from here, well, we know what vector OA is. We know what vector OM is. We can also try to figure out what vector MA is, and then we can find out the angle between this. This can give either the acute or the obtuse angle, since there are two angles involved. So the vector OM is just equal to this. Vector MA, on the other hand, will be equal to 5/4, 5/4, 2, and then 1/4. So the angle between these two vectors, now this is a bit messy problem. So the two vectors that we had are 3/4, 0, 3/4, and the other vector is, the other one is what? 5/4, 2, and then 1/4, 5/4, 2, and then 1/4. These vectors, let us just name them as A and B. The angle between them is cos inverse of A dot B times the magnitude divided by the magnitudes of vectors A and B. So A dot B gives you what? 3/4 times 5/4 is 15/16. 15/16. 15/16 plus 3/16. The 0 into 2 does not factor in. And this divided by the magnitude of vector A. This is 3/4√2. And the magnitude of this thing right here is 25/16 plus 4 plus 1/16, all of this under the square root. This gives us 26/16 plus 4. Now this does not look like a likely contender, but still, let us just try to solve it. So what does this give? This gives us 64. 64 plus 26 is 90. So 90 90 by 16. I don't think so. There are any common factors except 2. So 45 divided by 8. And well, what does 45 stands for? 45 is 3 root 5 divided by 2 root 2. And so we can write that in right here. 2 root 2's get cancelled out. And what else can we do? We can write this as 9 root 5, and the 8 right here goes on top. So 8 and then 18 by 16. So this is what? 9 by 8. These 8's cancel out, so you get 1 by square root of 5. Now, cos inverse of 1 by square root of 5, this is not equal to pi by 3. This is not equal to the angle that we were supposed to get. So D is not correct. I hope so, if we have not committed any calculation mistakes. And the answer is A, B, C. Or answers, more correctly.